Oh, we're recording?
It's recording.
Okay,
right
bond
now.
polarity. Good, it's recording.
It is recording.
Okay.
Hey, bond polarity.
So we've got a picture here of a periodic table with a bunch of funny numbers on it, all from, looks like 0.7 up to 4.
What do those values represent?
Those values actually represent something called electronegativity.
I thought we were talking about polarity.
Well, we are, but we need to know what electronegativity is before we can talk about polarity.
Okay, so electronegativity is related to polarity.
Yes.
Let's figure out how.
Indeed.
Electronegativity is a value used to determine how much an element pulls on bonding pairs of electrons. Okay.
So the most electronegative elements actually end up in the top right corner of their periodic table.
So, nice typo.
Yeah.
So you can see where they're more red here, they're more electronegative.
Yeah. It's interestingly, you see those ones over to the far right? They don't have electronegativity values.
Oh, those are the noble gases. So it's the top right corner of the periodic table excluding the noble gases.
Yeah.
Because the noble gases don't react with anything. Here's what an electronegativity talks about. If we have a bond with fluorine and it bonds with itself, there's 2 electrons in that bond, right? And they share them. Essentially, they're trying to tug of war those 2 electrons because they may not be shared equally.
Yeah. And the thing is, they're both fluorines, and they're both going to pull on those electrons with equal strength.
Yeah.
Say, if you had a twin sibling who was the same exact size as you and you were playing tug of war, it would be a very difficult game of tug of war.
So these 2, since they have the same electronegativity value, they share the electrons equally. But if we had fluorine in a tug of war with hydrogen over those 2 electrons,
Man, poor hydrogen.
I know, hydrogen only has a value of 2.1. That's not even fair. Fluorine's like twice its size, 4. So what's going to happen?
So that basically just means that the fluorine is going to pull the electrons much closer to it than they are going to be towards the hydrogen.
So the electrons are getting pulled in that direction?
That's right.
So what's that going to do to the fluorine?
Well, I think it's going to make it slightly negative because you're pulling electrons, which are negative, close to it.
So this is covalent bonding. It doesn't have a -1 charge, though, does it?
No.
It's just a partial charge. So we designate that with this little symbol here. It's a partial negative because it has extra electrons, but not all the way extra electrons.
So if the fluorine's pulling some of the electrons towards it and it's partially negative, that must mean that the electrons are being pulled away from hydrogen, and it is
Partially positive.
Yeah.
There you have polarity. You have 2 poles. You have a negative end and a positive end.
It's kind of like the North and South Pole, but
Yeah.
it's electrons, not magnets.
So in a bond, when you have 2 atoms that with different electronegativity values, they don't share electrons equally because of the electronegativity. So here's another example with words this time, and this just has the values pulled out. We have a difference of an electronegativity. The bond is polar. Fluorine and Cl. What's going to happen?
So we got fluorine's electronegativity at 4, chlorine's at 3. This is a little closer together than the last example.
Fluorine's going to win.
Fluorine's still going to win because it's still more electronegative, so it's still going to pull the electrons towards it.
Fluorine's negative, chlorine's positive. Again, we have a polar bond.
All right, some examples. Relatively simple examples, but we're going to look at it and see if the chlorine to chlorine bond is polar in a chlorine molecule.
I noticed that they're the same exact atom.
Yeah.
So I think they're going to tug of war equally, and this is going to be non-polar.
It's that simple. We're just looking at see if they're the same or not the same, right?
Yeah, but you need to be able to explain the electronegativity part of it. You can't
Yeah.
just say it's the same or not the same.
Right.
It's because of the pull of the electrons. One of them pulls electrons. What about this one, LiCl?
Well, these are 2 different elements,
Okay,
so it's definitely polar.
polar's good,
But
but
why?
which one is positive, which one's negative? Well, chlorine is closer to the top right because those elements, excluding the noble gases, are the most electronegative on the periodic table.
So chlorine's going to pull the electrons much, much closer to it than the lithium is going to.
Which means that'll be negative and that'll be positive because it's pulling extra negative charges, extra electrons. That is bond polarity.